Yeah, hi and welcome. Can you hear me? Hello.
Hello.
Yeah, can you hear me?
Yes.
Okay, thank you. So let's go straight to this session. So basically, we discuss about the total three topic. Okay. So one topic mainly how to predict land surface temperature, mainly LST, how to predict LST. We also discuss about that, and also discuss about that correlation analysis, correlation NDVI and LST correlation, how to work. We also discuss about that, and also discuss about that how to work with Python machine learning. Okay, for the making the land use land cover classification. We also discuss about these things also. Okay, so this type of topic we also discuss one by one. Okay, so let me share my screen. Can you see my screen? Is it visible? Can you see my screen? Yeah. Is it visible?
Yes.
Okay, so let's go discuss about that. Yeah. So here I already opened some project work, my previous project work. So I try to explain this type of things. Okay. Otherwise, when I write the code, it take a lot of time. Okay. So just I explain all of code line by line. Then I hope it also help you. Okay. And after the class, I also send you all of practice code. So then you can also easily adapt this type of code for your own study area. Further, if there's any problem, then you'll also discuss about that. No problem. Okay. So first of all, we simply discuss about that LST prediction, how to make LST prediction. So if you simply search some scientific paper about the LST prediction or land surface temperature prediction, suppose I simply open the Google Scholar, what types of method they use, we try to check it because there are a lot of method to predict the LST prediction, LST future prediction using remote sensing. I simply search LST future prediction using remote sensing, mainly satellite data. So if you check, it's one kind of paper, remote sensing based prediction of temporal change in land surface temperature and land use land cover. Okay, so basically in this paper, they are predict LST, temporal change, okay, prediction, temporal changes, and also land use land cover in the urban environment. So this is another, you can say, investigation and predicting land surface temperature based on remotely sensed data during this time. So let me open one paper, then try to show you the method, what types of method they're using here, or what types of algorithm they are use. Basically, there's a lot of method in here. So let me try to show you that for this paper. To check, this is the work, and in this work there are mainly land use, land cover, and LST. Their use and predict the land use land cover change and also LST change. Okay. If you check the method section, it will be more better. Data, material, and method. So the study area. So this is the study area. And data acquisition, they are used here, I think, Landsat satellite data, because they have the thermal bands. Landsat data have the thermal bands, which help you to estimate the LST. And if you check the framework, so this is the framework. So in this time, their input data, mainly temporal satellite image, they are used, and also use the some meteorological data. Okay, meteorological data they also use. So from the satellite data, so mainly their image pre-processing, land use, land cover classification, and change detection, and also check the accuracy assessment. Okay. And after that, image from the image processing, they also take some indices, NDBI, and also compute the emissivity. Okay, emissivity also compute. and also take the thermal bands and take the DN radiance conversion, and after the bright radiance of the brightness, temperature, and emissivity. So these two things help you there use the LST. Yeah, they make the LST about that. And further, they also use LULC analysis and LST prediction, help of the meteorological data that is taken in here. Okay. Okay, so there you can see land LST and land use land cover. They take the 1,200 random sample points. Okay, they use this type of random sample points, and they use this type of things. Okay, up accuracy also use this type of formula. So this is the LST. They use this type of formula for getting the LST from satellite data. And after the LST, they also make the land use land cover classification. Okay, so you can see that use this type of decade. Okay, and also take all of the accuracy also computed. Okay, so mainly you can see they are computed, make the classification for build up, water body, vegetation, and barren land. They are not make the complex classification, they are make the normal classification, not make the complex. Only they are classified build up, vegetation, water, and barren land. Okay, so I think it also more better. So maximum paper, when they are used for the prediction, they are not use the complex land use land cover data. They are take the normal data, build up data, water body, vegetation, and barren land, and make the classification. Okay, and further they are make the change detection also, you can see. Okay, and also change in urban area extent, mainly urban expansion, they're also displaying this map. So different year. Okay, urban expansion, they're also displaying here. Urban expansion spectral indices, they also use this type of and land surface temperature. So they take the land surface temperature from Landsat satellite data. Okay, so you can see this the Landsat data they're also using here. And LST versus spectral indices, they also make some correlation. Okay, mainly LST. And then you can see make the relationship between LST and land use land cover pattern. Okay, so what's the pattern about LST and land use land cover pattern? So you can see, so build up area, you can see there make the correlation relationship between build up area and LST. Okay, so you can see it's increased the temperature. Okay, in the between the when you make the correlation between build up area and LST, it also increased. So today also discuss about this type of correlation also, how to make correlation between two different variable. Okay, LST and or NDVI, or LST and build up area, or LST with NDVI. So different types of things we can easily do. Suppose in this time if you check for the build up area and mean LST, so they are identify build up area and mean LST and make the correlation, and it show the increase the temperature. Okay, so you can see when the build up area increased, as well as also LST is also increased. Okay, as well as you can see that display all of those validation, land use land cover, LST, and future trend, they're also using here. Okay, mainly LULC and land surface temperature. Okay, they also use this type of things. And for prediction, if you check, they are predict 2025 and 2030, I think 2030. Yeah, they are predict. Okay, so they find this type of result. So build up how much area increased, vegetation how much area decreased. You can see bare land and water. Okay. You can see the prediction of LST suggests that mean temperature is continuously increasing. Okay, so they are finding this type of result. And future projection of LST were made by existing trend retrieved from the temporal satellite images. To validate the future prediction result, first the trend for the year 2020 was predicted, then compare the values with the retrieved satellite data. Okay, so they are used this imagery. Okay, so that is the predict. So you can see basically in this time they are predict for only for numerical data. Again, they are not predict for the satellite data. They are only, and if you check, I think they are not display any kinds of prediction map. This paper you can see not showing any kinds of prediction map. So it just show the statistical value. Suppose I have some previous data. So based on the previous data, I simply predict for 2025 or 2030. Okay. Same like is for LST. Suppose I have some data, previous year's data of LST. So based on the LST, they predict. Okay. Help of the statistical, different types of statistical function were used, and then we can easily predict. And it's called the numerical condition. Numerical condition only for the numerical data, not for your raster data. Okay. It's a numerical number. So we are use here the linear regression, and also use suppose different types of method to make the predict. So it's one kind of method. It's mainly show you the only for numerical value number. Okay, numerical value. So this is the one kind of method. As well as we also use some, suppose we also use some other different types of plugin. Suppose Mollusk, QGIS Mollusk plugin. So inshallah I try to show you all of those one by one, then you can easily get the idea how to predict for land use, land cover, or how to predict LST. But this paper mainly discuss about that only for based on the numerical data. Suppose I have 20 years data. So this 20 years trend I just use, and further I predict for 2030. So look like this. So it's one kind of paper. Okay. So they are not use any kinds of plugin. They are not use any kinds of image prediction map. If you check this paper, is not have the prediction map. Just they are use some previous data and then predict. So it's one kind of method. Okay, you can see this is one kind of method. So they are use the previous data, and further they are use this type of trend, just mainly numerical data, just make the trend and make the prediction. Okay. So as well as also, let me show you the another paper. But there's LST future predictions. Suppose using machine learning. So this is the predicting impact of the land use, land cover changes and seasonal urban thermal characteristic using the machine learning algorithm. So they are used some machine learning. So let me explain this paper. What types of machine learning they are used in here for predicting. So you can see predicting the impact of the land use, land cover changes on seasonal urban thermal characteristic using the machine learning algorithm. So in this paper, it's mainly identify land use, land cover, and also identify urban thermal field variance index. So it's mainly identify effect of urban heat island. Okay. And further, they are make the correlation between the two variable, land use, land cover, and urban thermal field variance index. Okay. And now prediction. So let me show you that for the prediction method, what they are using here. Estimate this paper. Not freely available. Just a So this is the, well, let me show you that. Okay, so as you can see, they're using that this model, CA Markov model and artificial neural network. Okay, so annual LST and future scenario, mainly future prediction. They are used the CA Markov model and artificial neural network. Okay, so it's also another method basically in this one kind of machine learning method, CA Markov model and artificial neural network. We can also apply, and then further we can also predict. Okay, for the land use, land cover, and also predict the LST. Okay, and predict the future variation land use, land cover, and LST. Okay, in this session they use the CA Markov model and predict for 2035 and 50 they predict, okay, using this model. And if you check what types of tool or what types of software they use, so if you check, this is the method. So mainly they are use land use LST, they are use the Google Earth Engine, okay, and ArcGIS, ANVI, or also QGIS software. So they are use this type of software to make this type of mapping or analysis. And if you check the land use land cover classification accuracy and assessment of the seasonal and annual LST. So they are used at the seasonal annual LST computed from the Landsat imagery, and for different year 1998, 2005, and 2020. Okay, they are used, and then compute the LST. Okay, so this is the LST method. Okay, really brightness, temperature. Okay, and then simply get the result for LST. So this is the proportion of vegetation, surface emissivity formula. So this type of formula I already discussed in my previous classes how to work. Okay, so I already know about that. So now we talk about the LST prediction help of machine learning method. Okay, so you can see the LST standardization they're also using here. Okay, you can say simulated LULC for the future period. Okay, so this is the simulation of the land use land cover for the future prediction. So in this case, if you check in this study, basically it uses the CA Markov model, simulation for land use land cover prediction this time period. So they are using the CA Markov model, and land reconstruction process, then availability of the data set and the research objective, and the accuracy of the prediction. So they are used at the CA Markov model, which is best for their research work they're also using here. So this is the, if you check the for the LST simulation of annual mean LST of the future period. So for the LST simulation of the future, they are use the past data trend. Okay, so for the LST simulation based on the past data trend, the artificial neural network model analyzes the previous estimate LST values, okay, and understand the trend in the data and predict the future change. Prediction of the LST, okay, network of the certain, targeting of the network performance, evaluation, simulation of the prediction. Okay, they're also used at the artificial neural network. Okay, so LST, if you check, LST is also use the artificial neural network model and then predict, okay, for the your analysis. Okay, and if you check the root mean square error, they also compute the root mean square error, okay, R square value to identify the hidden layers. Okay, so these type of things they also use in here. LST prediction. And if you check, this is the analysis about that. And if you check, they also provide this type of map. And this is the change detection analysis. And that also again the seasonal, also take seasonal data, reference season, and this is the map. And you can see the simulation of the future land use land cover dynamics. So this is the future prediction map. And they also compute the area, how much 2035, how much 2050. And you can see the LST, future mean LST. So you can see it show this type of map. Okay, 2035 and 2050. Okay. And if you check, they are used for the LST simulated with 2035 to 2050 using a hybrid CA Markov model and artificial neural model. Okay, so they are using here. So CA Markov model and artificial neural network. So maximum prediction simulation, they use this technique, CA Markov model and artificial neural network. So this CA Markov model and artificial neural network, how to use. Okay, so initially I discuss about the more practical things, then you can easily get the better idea how to use this type of CA Markov model and artificial neural network, then you can easily get the idea. Okay, so it's one kind of method for the prediction of the LST. Not only for that, we also use the another method It's called the regression method. So let me also some paper regarding suppose LST, future prediction using regression. So you can see, so let me open it. So this is the urban land surface temperature forecasting, a data-driven approach using the regression. Mainly they are using the regression method and neural network. So two methods using the regression method and also neural network method. So if you check this method, let me open the method section. This is the study area and methodological framework. So first of all, you can see land surface temperature LST. They are estimated for 2004, 2009. Oh, sorry, 2009 and 2014 and 2019. Okay, so they are use the LST. Okay, they are compute the LST. And after the LST, if you check the framework, so in this framework, they are estimated the land cover, the urban vegetation, water, and others. Land use maps, accuracy assessment, and selected land cover representing its class. And temporal land cover, they apply the artificial neural network and predicted land cover. Okay. And if you check the temporal land use, so see a Markov model, predicted land use, and extract the land use classes. So same selected stack the land cover, multiple they are used at the multiple linear regression relationship between the LST and LC and forecast the LST. So same as you can see selected the input they are used at the LST, temporal LST or DEM data they are also using here again. And then relationship between LST and input and forecast the LST. So in this time we mainly focus these things in here. Okay, so how to apply the linear regression and predict the LST. So I try to discuss about this session. I discuss about this part. So mainly how we can easily select okay different types of input. So in this case, if you check my code, I already import some data. So I want to make the correlation use some data. Suppose in this case I take the rainfall data, then I take the previous LST data. Suppose my any data set, it can be previous LST data, and then I also take the population data, population density data, then take the DEM data. Okay, and after this all of this I want to predict suppose LST base rainfall data, then population density, then DEM data. Okay, so I want to use this type of factor as a factor. I want to use this type of data, and then I predict for LST using the regression technique. So I'll try to explain this thing, then you can get the better idea. So first of all, from the rainfall, I just compute the total rainfall. So just I call my rainfall data, and I simply compute the total rainfall. Okay, just I use the sum. So now it just calculate the total rainfall, and further I simply display the rainfall map. So just I run the code, so it display the rainfall map for my study area. So here is the high rainfall, where is the low rainfall. You can easily get the information from here. Okay, so let me open this. So okay, so let me just stressing and get the better value and get the better result. I think it's better. So just I stressing, I keep 98%. Okay, just I copy this value and apply in here. It's a okay. It's I think it also it's some problem. So it's a minimum. I put this value, and this one is maximum, and it is a total rainfall here for this study area. And so in this time, we can see this type of color. So this type of red color indicating about the high rainfall. Okay, so let me add the suitable color. Suppose I simply use or just a change from here. You can see just I simply put here. Suppose I put here. It's a suppose red color. Then put the yellow color. Then put the Suppose I put here, sorry, purple color, cyan color, green color. I put here it's a blue color. Okay, so blue color it's indicating about the maximum rainfall. So and red color is the minimum rainfall. Okay. So just I put this type of color to looks more pretty map. So just I click. So now it create. Oh my god. Let me run again. I just apply. So now it's look more pretty. Just I use it. It's a minimum and this is a maximum. I just simply put here. So now this color is set with my map. Just apply. Okay, now it's look more pretty. Okay, let me import from here. I think it's better. Otherwise, when I run, it will be gone. So now I just call the visualization parameter. Just take copy. And I just put the variable in here. Okay, so let's set it. So now if you check, we find out this type of map. Okay, so we find out basically this type of place, rainfall, maximum rainfall, we find out this type of place. And if you check this type of place, it show the minimum rainfall. So we find out this type of map. So it's a rainfall distribution map. Where is the high rainfall we can get. So this is the one kind of data. So this data we also use for prediction as well as LST data. So this is the LST data. So I simply compute the average LST, okay, and multiply this value to get the result, mainly reprojected the scale value and add with basically this value. Simply use it 273.15. So then it will be compute the result in degree Celsius. Okay. And further, I simply display this map in the LST map. We simply display. So now run the code. So now it's added the another map LST. So we find out if you check this type of LST map. So here is the high LST. We can easily get it from here. So this is the LST map as well as also population density. Okay, here is the high population, here is the low population. So for the population density, simply use this data. So this is this data, world population. So this data we simply use to get the population density information. If you check it, this is the global projection. Okay, so this data. So this is the population band, and it estimates the number of people residing in a east grid cell. Okay? And this is the band. So we simply use this population density map. We simply compute from here. So now run the code, then we can easily get the population density. And black it's indicating about the low, white is the high. So we simply display this map. So we find out if you check. So if you check, we find out this type of information. So basically, this type of place is the high density of population. Okay, this type of place. Okay, this type of place is the high density of the population, and black is indicating about the low density of the population. Okay, but this type of place is the high density or high density population density. Find out this type of place. Okay, and this type of black place is the low population density. This type of place. Okay, so it's one kind of information about the population. After the population, we simply take the another which is the elevation, mainly high elevation and low elevation. So we simply use the NASA SRTM DEM and add the DEM information. So if you check, this is the elevation. So it look like that. Okay, so if you stress, then it will be look more pretty. Just stressing. Actually, it's optional. Okay, so it's optional. But if you want to also visualize more better map, then try to stressing. Then it will be look more pretty. So you can get this type of map. Okay. So this type of place is the high elevation. We find out that. Okay. And this type of place is a low elevation. This type of green field is a low elevation. We find out. So this is the elevation map. So we simply add all of those. So in this case, I simply apply elevation, population density, then LST, and also use the rainfall data. So I use total 4 data set to predict the LST. And after that, I simply combine all of those together. So all of those we simply combined. So combine rain, combine LST, combine population, and elevation max. Okay, and update marks with the population. So just we simply combine. So after combine, we simply extract the sample. So in this time we can say we take the 10,000 sample. So we simply extract from this map 10,000 sample, 10,000 point, 10,000 point sample it generate. So if you just simply display, suppose just I simply display the all of samples just on the code. So I take the total 10,000 samples. So if you just open the samples, so we can get this type of sample. Basically, it's one kind of point. You can see this type of point. So I create this type of 10,000 samples. And this type of samples, it extract the information. It extract the information, mainly extract the pixel value of rainfall, pixel value of LST, pixel value of elevation, pixel value of population. It extract this type of points. If you want, you can simply print, suppose sample. First, let me print sample. I just take the first item I want to display. Just run. So if you check it extract that, you can see the for this sample, it extract the LST value, it extract the elevation value, it extract the population, it extract the rainfall, and random. It extract this type of value. So it extract all of values. So this type of 10,000 pixel. Okay, suppose this type of 10,000 pixel, we simply use and extract the data and extract the data. So this data I want to use further, and then I apply the linear regression method. So I simply apply the linear regression method. And further, we simply check it the result. So we find out this type of things. So now when we apply the linear regression, this data set is simply split into two ways. Okay. Suppose I just use some data for train my model and some data I simply use for test my model. Mainly we simply split train set and test set. Okay, train set and test set. So further we simply apply, take a variable, suppose train. Okay, and also call the test. So we simply apply train set and test set. Suppose 80% data. So 80% data we are just used for train our model, and 20% data, this data is simply used for check our model performance or check the accuracy of this model. So 80% data and 20% data we simply use. So I simply just apply train set and test set and take the randomly 0.8 and greater than 0.8. So now my data set is ready. If you want to check it, suppose 10 size and test size, you also check it from here. So total train size and total test size. So these are train size. So we just simply train our model using the 8,000 sample, and rest of the 1,903 we simply use it for test our model or test our performance level, okay, of our model. So we simply apply this train set 10-hour model, and in this case we simply apply the random forest model. It's called the random forest model. We simply apply. So just I simply apply the random forest, and I apply the regression. So in this time we simply apply the regression, mainly y equal to mx plus c. So y is for predict LST, prediction of LST. M basically slope value, and x basically actual LST value, x and c mainly intercept value. So basically linear regression, y equal to mx plus c. So this thing we simply apply y equal to mx plus c, and then predict the, okay, so help of random forest model. So then we simply prediction. So just I simply apply, take a variable, suppose prediction, and call the combined and classify it with the regression. Then it display the LS prediction map of LST. So now open it. So if you check this, the LST prediction layer, it better just I simply stressing and then show you the better visualization. So we find out this type of map. Okay, and this is our actual LST, and this is our prediction LST. If you check it, we find out this is our actual LST. So this is the actual LST value, and this is the prediction. So this is the prediction you can see. So if you just increase, so it show the LST prediction. So this type of place is increase the temperature, it display. Or if you check it's about, just click on the inspector tab and click on this map, visualize. So it show the prediction actual LST 45.91, but prediction LST if you check 45, okay, 26. Okay, so it also show this type of temperature, not much increase or decrease. So just click on here. Okay, so you can see it show the 44.80. It will display this type of things. Also you can see the LST 44.72. And if you check, it just show only this type of place. So basically in this time it just mainly change the LST, increasing or decreasing the LST between only for this type of place it discuss. Okay, suppose where there is not change, that it show the null value. So this it show the null value. So in this time this type of place suppose not change, so where we find out that there is no data, so it means that this type of place is not change. But where is the change, it show this type of value if you check. So we find out. So this type of place is also increased the temperature. Okay, some place also decrease the temperature. You can see this type of place, so also decrease the temperature, this type of place. And this type of place red color, it's also increase the temperature. Okay, so it's one kind of method, it's called the regression method, okay, to predict the LST. And also see this type of place, it will also display about that it also decrease the temperature, okay, based on our data set, because it's near to the coast. Okay. So now we find out this type of future LST change. Okay, for this type of place we find out the change, where is the increasing or here is the decreasing. So basically this type of place it indicating about the decreasing the temperature, and this type of red color it also discusses about the increase the temperature. So now what's the accuracy of your prediction map? Okay, what is the accuracy of your prediction map? So for that, we simply compare the analysis. Basically, we just simply create the linear regression chart. Okay, so here suppose x column and y column display the actual value and predicted value, and further we simply compute the r square value, okay, or root mean square error value. So then it will look more pretty. So let's get ready to show you that. So for the classify test data, so I simply open this to test data. So we simply call our test set basically 20% data. So this data is simply useful for our your accuracy. So this data we simply apply now with our regression model, and further this thing we simply apply as a chart. So let me just open the chart code and show you that. So let me just open the chart code and now run the code. So now it create a chart if you check, and from the chart it display the all of things. Okay, so if I know you can see this type of things. Just let me open. So it just show me two information: LST actual value and LST prediction value. Okay, and if you, it show the R square value, you can say 0.6. So we find out this a strong correlation between the two data, LST prediction data and LST actual data. We find out this strong positive correlation. And if you check this the LST prediction, we find out that y equal to mx plus c. So you can see this is the m value, and this is the x basically your actual LST value, plus c basically it's your intercept value. So this is the LST prediction, and if you check it show two line. So one line is for prediction line, another line is for actual LST. Okay, LST prediction and actual prediction. Okay, LST and actual LST. Okay, prediction LST and actual LST. So you can see it show the actual LST, this type of value. So from you can get the strong positive correlation 0.69. Okay, strong, and this is the your linear equation for prediction y equal to mx plus c, help of linear regression y equal to mx plus c. So here y mainly LST prediction, m mainly it's a slope value, x it's a LST value, actual LST value, plus c basically it's your intercept value. Okay, or you can also download all of data as a CSV and also download the PNC file format of this data. Okay, any question anyone please, or any confusion? So it's called the linear regression based prediction. Okay, we simply apply the linear regression and then we simply predict. So I have the actual LST value. So now what is the predicted LST value based on some factor. So in this time I simply add some factor, rainfall factor. I also add suppose population density factor. Also use the elevation factor. Okay, so this type of factor is simply used and then we apply the linear regression. So you can use different types of factor for prediction. There is no problem. Okay, any question?
Yes, sir.
Yeah, please.
The LST prediction, is it in years?
Which one?
This one, is it years? Yes.
Oh, yeah.
Yes?
Yes.
Okay. Thanks.
Okay. So this is the way. So actually not only for this type of prediction, any prediction, help of the regression. Suppose I have some actual NDVI value. Suppose I have some I have a NDVI map. So I want to make the prediction of the NDVI based on some factor. So just apply the same process. So basically for the future prediction, we can apply different method. So I already show you some paper. So different paper use the different types of method. Some paper use the CA Markov model and artificial neural network model. Some paper use the linear regression model. Okay, some paper use the forecasting land surface temperature help of the linear regression or multiple linear regression model and identify relation. So I will send you this type of paper also. So you also try to read this type of paper to get the more better knowledge. So CA Markov model, inshallah we discuss about the further class, then you can get the more better idea how to apply the CA Markov model and artificial neural network also predict for land use land cover or LST also. Okay, so then we need the trend of the trend data. We need, suppose I need the LST for different year, then I simply use the artificial linear network, or also apply the CMR model and then predict the LST or predict the land use land cover. So inshallah we try to discuss this type of things. Previous upcoming classes, inshallah we discuss about that again. So now one thing is very important. We also discuss about that. Mainly it's called machine learning. How to apply for land use land cover. Okay. So I also write it, machine learning. Machine learning for LULC. So in this case, how I can create my data set when I apply the machine learning for land use land cover. We already use the land use land cover analysis using the Google Earth engine. So if you check in the Google Earth engine, I hope you already know about that. I already discussed in my previous 7 days class how to work with different types of model with the from the docs tab. It provides you that a lot of model. You can see the random forest model, or also we can easily get the different types of classifier, okay, from the docs tab. And how to work with Google Earth engine for the classification of satellite imagery, we already discussed about that. Okay, and for that it has some limitation. So basically it's one kind of ready-made function. Okay, so if you check, it provides all of ready-made function. It's a ready-made function, all of those. I can see it's provided a lot of algorithm, but this type of algorithm is ready-made. We cannot modify, you cannot this any it's called the pre-trained, okay, this type of data or this type of function. So you can see this type of, we already use how to use this type of things. But not only for that, we can also use the, in the advanced class we discuss about that some advanced topic of the land use land cover classification. Okay, how to apply the machine learning, okay, how to apply the deep learning. So this type of things I also try to explain. So for that, first of all, we need to learn about that how to get the data. Okay, mainly how to get the spectral signature value, how to get the image. So these type of things I also try to discuss about that. So basically, first of all, we need to install some package. One package, rasterio package, we need. Then GeoPandas, and also need the XGBoost. So when you apply the this type of gradient boost model, we need the XGBoost. So this type of things I simply install first time. Just I simply click. So now it just install it in my Google Colab environment. It takes some time for the first time. So Rasterio, GeoPandas, and XGBoost. It's working. Okay, I hope. Yeah, it's working. And installing the Rasterio, GeoPandas, and XGBoost. Okay, so now continue, please. Yeah. So just it's installed. If you check, so further, okay. So after installing all of requirement library, we need to import our image. Okay, we need to import our image. So you can see I already, okay, so let me show you the image. So my image is stored in my Google Drive. So you can see that this is a drive. So in the drive, when I just simply click go to the my drive, so I already stored my image, which image I want to classify. And my folder name is, okay, let me open my drive LST folder. So here is the folder. Um, this one. And if you check, this folder already have the image Sentinel-2. Okay, so this image Sentinel-2, where is it? This one. Okay, Sentinel-2 2023 Dhaka. So just I simply click and copy the path. Okay, then I simply paste in here. So basically this directory I stored my file. I stored, this is the path of my image. So just I run it. So you can see there is no problem. So this image after import in my code, then I need to import rasterio and also import the rasterio.plot.show. So these two library is simply imported, and then I just call the rasterio. So basically rasterio is one kind of Python package. It's handling the raster image. Okay, mainly open the raster image, reshape the raster image, display the raster image. We use the rasterio. So just I simply call the rasterio and use that open function, rasterio dot open. I want to open this image, and this image is stored in this variable. Just I call the variable name and store it in this variable CRS. So now run the code. So now it opening. Okay, so now number of band I want to count. So how many number in my image I want to compute how many band. Okay, so further just I call this variable name src and apply the count function and run the code. So now it's count how many band. I have total 12 bands. Okay, so this image I have total 12 bands. So then also use suppose a special extend area I want to check. Okay, a special extend area. So for that just use the bounds function. So this is another function bounds. Just I use. So now it show me the special extend area. You can see. So left, right, left, bottom, right, top, all of coordinates well I can get in here. So I want to check what's coordinate system of my image. Coordinate system. So for that simply use the CRS function. Just I call the src because src is stored my image, and I apply the CRS function to check the coordinate system. So you can see WGS 984. This is my coordinate system of this, and I want to check some resolution. So for this image I want to check the resolution. So just use the res function. So this is the res function. It's mainly compute the resolution of your satellite imagery. So we can get this is the resolution or pixel size about the satellite imagery. So we find out this type of things. Okay, and I want to check some profile. It give you, this is the another function profile. It give you the all of metadata of your image. Just a run. So now it display all of metadata. Okay, so you can see all of metadata. So it's showing the image width and height, image height and width. Or you also get the band. Okay, also get the CRS information. Okay, all of information you can easily get from here. Okay, when I use the profile function. So profile function, res function, src function, bounds function, and count function. It's very important when you check some metadata of your image, then we just apply. Okay, so after that, suppose this CRS I want to open. So for that I simply take a variable img and I call the CRS and use the read function. Okay, read function, just run it. So now if you check, it just read the all of information from this image. So now I want to check the image shape, mainly row and column. Just run here. So if you check it, show that the shape of the image. We find out shape of the image. First of all, band number. Okay, how much band? Then row number. Row. We find out this is the row. and this is the column, how much column. So we find out that. So after read the image, when I just apply the shape function, so just it give me the information, band, row, and column. So this is the band information, how many band in my image. This is the rows, and this is the columns. So we can easily identify band, rows, and columns information. So after that, I simply print type of image. So it's just show you the numpy. So image is a numpy array. We find out. So now I want to read, suppose band. Okay, so just src read one. Just I call it band one, and I want to display the image. So for that, I simply apply the matplotlib.pyplot as a PLT. So it's mainly help you to display the image or create the graph or chart or plot. So I have to display. So I want to plot, suppose this band one. Okay, just I click on here. So now if you check, it display the imagery look like that. So it show the band one. Okay, it show the band one. Only band one visualization. Suppose I want to display, suppose another band. So just I simply read, suppose just put it, suppose band 4. Just run it, and now run it. So now display the another band. So this is another band it display. Okay. So you have to change the title from here. Suppose I put the band 4. Now run the code. Let's show that's a grayscale color. Okay. Let's show the grayscale color. But you can use also, suppose I have to display the another band. Suppose band 5. Run it. And I want to plot. We can get this type of near infrared band look like that. Okay. And if you just check the shape of the image, so we can get this type of shape. This image have total 12 bands. This is the rows, and also get the column. So you find out this type of information of this image. Okay. So now we simply apply all of those together. Suppose just I apply all of important library which I need. And we need to apply the transpose. So what is the transpose? It's very important. Transpose. So if you check, it show the band. Band is the 0 number item, 0. Then row is the 1, and column is the 2 number item. So 0, 1, and 2. 0, 1, and 2. So now I want to change the serial. I want to change the serial. Help of transpose function. So I said, first of all, I set 1. 1 basically row. I simply set the 1. Column is the 2. And then I set the 0. 0 basically band number. So I simply use this transpose 1, 2, 0, 1, 2, 0. So when I apply, then it changed my shape. If you check now the new shape, so you can see now first time it show the rows, then column, and finally it show the band. Okay, so just we apply the transpose and we simply change the image shape. The first default shape is 0, 1, 2. 0, 1, 2. 0 mainly band, 1 mainly row, and 2 mainly column. But when I put the transpose, I set 1, 2, 0. Then 1 is the rows, 2 is the column, and 3 is the band. I find out. Okay, so it's neat because part I also use only for the rows and column. So it's important. We need to use the transpose for that. So now if you check, I simply select the band, red band, green band, and blue band. So I just call the image this variable, and if you check, I put the empty, and put the band number, because the 0, 1, 1, 2, and 0. Okay, 0 is the band. So this serial is the band. So I set the band 3, band 2, and band 1. Okay, band 3, band 2, and band 1. And you can see it's a rows and column. I simply empty. Rows and column, I simply empty. Rows and column, just put the empty. I don't put anything. I just put the number only for band section, because this is the 1, this is the 2, and this is the 0. 1 is for rows, 2 is for column, and 0 is for band. So I simply put the band number, look like that. So now run the code. And now I simply create the stack. So red, green, and blue, I just make a composite red, green, and blue, and also put the figure size and image. So now run it. So now it display the RGB red, green, and blue. So we find out this type of satellite imagery. It look more better with visualization. We find out that. Suppose I want to display another. So I put here, suppose near infrared. It's a 4. It's a 3. Suppose I want to put this type of things. So now you find out this type of band combination look like that. Okay. So any band combination you can display from here. Mhm. So I'm going to display this. So now it shows this type of band combination. So different types of band combination is set from here. Okay. So now this is our satellite imagery. We simply create, and now I want to use it to now I just simply apply training sample. I need the training sample. Okay. So for the training sample, I simply create the training shape. I already create all of sample as a shape file. Okay. Suppose and it's stored in my Google Drive. Okay. In my Google Drive folder, I already make the shape file all of sample. If you check it the sample from here, just I simply use the GPD, mainly GeoPandas, and read the file of sample. So when I just and then it show, you can see it show the all of information. So first of all, class, it mainly show the level 0, 1, 2, 3, all of level. Then if you check the sample B1, mainly B1 spectral signature value, B2, B3, B4, and all of spectral signature value. Okay, I have already all of classes. So these things, how I can create, it's very important because we need to use it for our extract the information. We need to extract the information, this type of pixel value. Pixel value. We need to use this type of pixel. We need to apply the pixel, and then it just extract the information. Okay. So this training shape file, we can use the Google Earth engine. We simply use the Google Earth engine and then extract this type of shape file. Okay. Shape file, then we can easily do it. So in this case, I want to suppose display. I want to display the training sample, all of training sample in my image, in my satellite image. So how I can display the all of training sample in my satellite imagery? So for that, we simply use the samples and apply the two CRS. I use the same CRS. If you check when I print, we can get. So this is the coordinate system from my samples, and this is the coordinate system for my image. Okay, both coordinate system must be same, otherwise it creates some problem. Okay, when you overlay the training sample, so you must use the same projection for the training sample and also for your image. So you can get this type of things. And further, we simply just run. So now if you check it, display all of training sample overlay with the satellite imagery. So if you see, we can get this type of imagery look like that. And if you check it, show the all of training sample. So this is the training sample is for water, then it's a vegetation or bare land, this type of yellow color, and red color is the build up. So this type of training sample is simply used in our model, in our machine learning model. We simply use, and then we simply make the land use land cover classification. So this is the primary process when you make any model using the Python or deep learning. Same, okay, we just simply take the training sample and we simply connect with the training sample with your satellite imagery. Further, this type of data is ready, we can easily apply any kinds of machine learning and then make the classification. Suppose in this case barren land, build up, vegetation and water, we simply classify. Okay, so any question you can ask me please in here, any question?
No.
Okay, I hope there is no question. You also try, then you can easily get. So this is our data set and image, how to visualize the shapefile of your training sample and how to get the imagery. And so the rest of the part initially we try to discuss about the next class. Okay, after preparing the data, how to apply the model. Okay, different types of machine learning model and then classified. Okay, so now this is the process ready. So further, inshallah, we discuss about the rest of the topic. Then you can get the more better idea. Yeah. Okay, so now we talk about the last topic, how to work with correlation. Okay, correlation between NDVI or LST or any other data set. Okay, how to make the correlation and make the correlation between two variable. Okay, and identify R value, mainly R square value. So for this example, here I said the two value. So in this case, simply take the modis NDVI value and also get the modis LST. Okay. So I take the two data set, modis NDVI and modis LST, and I want to make the correlation analysis between NDVI and LST. Okay. Suppose if NDVI high, then what's the happen for LST? Where is the high LST? What is the happen for NDVI? So this type of things we try to explore from here. So first of all, we simply import our dataset NDVI, okay, and then filter bound, then filter date. I take the data for 2020, and same like as for LST, I take the LST data. So I take the two types of data, NDVI and LST. We can use any dataset same way, okay. When you make the correlation, so in this case, I simply take the data for NDVI and also take the data for LST, okay, for the same time period. And then we simply convert NDVI scale factor 0.01 and also LST scale factor 0.02 and subtract this value to get the result in degree Celsius. Okay, so just apply this type of things in here. Okay, so it's just we simply rescaling our data for NDVI and also LST for rescaling the training data. Okay, so NDVI 0.001, simply multiply, then it reprojected the scale value. And for the LST, we simply multiply 0.02 and subtract this value to get the result Kelvin to degree Celsius. And now how I can make the correlation between NDVI and LST? Okay, so for that, we simply match NDVI and LST by date. Okay, we simply match the NDVI and LST by date, same date. So for that, we simply join. We simply apply the function join join.inner and apply this function. So I set the primary NDVI and secondary is the LST, and then we simply apply ee.filter.equals system time start and system time start. So based on the system time start, we simply join NDVI and LST together. Further, when I print the join, so let me show you the result first, then explain. I was just run the code. Run the code. So we simply join the two data matched by their date. If you check, it show this type of feature collection. So now it just simply create 23, and if you check, it show the property. So secondary, we also get and primary and secondary. So primary, secondary is mainly LST. Primary is for NDVI. Okay, and it's simply it just matched by date. Okay, same date, same date. Okay, for the two data set. Okay, so based on the time or based on the date, we simply merge. Okay, the two data set join. After that, we need to merge the band. Okay, so in this time, if you check from the primary, it show the NDVI band, and for the secondary, it show the LST band. But I need to merge NDVI and LST together. NDVI and LST, these two band just make the merge. Okay, merge mainly just stored in the one keyword or stored in one variable. So for that, we simply apply the merge function. Okay, basically this thing we need to apply merge function. We simply apply merge dot image collection dot image collection and joined the NDVI image and LST image base, and this NDVI image it get from the primary. If you check, basically it is straight to the primary for NDVI. Primary is for NDVI and secondary for LST. So you can see LST image feature it get from the secondary, and further we simply add bands LST image. So further we simply NDVI image and LST image just simply add and rename it as a NDVI and LST. So then when I use it and when I print, if you check, the two band just make the one variable or one keyword. If you check the features, just click on here, we can easily get the bands. You can see NDVI and LST. Okay, so you can get the just we can easily get the two bands. Okay, just merge. So two bands simply merge together, NDVI and LST. So this is the way we simply merge our band, and then we compute the NDVI and LST for our AOI. Okay, so just we simply compute, suppose average NDVI and LST. Just I run it. It show the result. If you check from the features, we can get it compute the information NDVI and LST. Okay, so this is the NDVI and this is the NDVI, this is the LST. Okay, for this time. Also you can see this is the another. So this is the NDVI and this is the LST for this time. So I just simply compute it. Okay, NDVI and LST value from the merged because this variable stored the merge of band LST and band NDVI. Okay, together. So when I compute the average NDVI and LST, so then I simply just create a function. So it's a function. So from this function, I simply compute the average. So this function I simply connect with my merged, because this merge is stored all of image collection with the band of LST and also NDVI. Okay, so it's simply connecting using the map function. So then it computed this type of things. We can check for every dates, it display the time, and for the LST and NDVI for this time average for this date. what is the average LST and what is the average NDVI, we can get it. So this mainly there are the three steps. First step, we simply mass by NDVI and LST by date. Okay, simply mass date by NDVI and LST. After that, we need to merge NDVI and LST. Okay, then we simply compute the average LST and NDVI. Okay, so this three step. So in this case, we simply use it for modis LST and modis NDVI, modis LST and modis NDVI. These same things you can also do using Landsat data. Okay, so Landsat. So from the Landsat, first of all, we need to compute the NDVI, then compute the LST. Okay, then apply the same process. Okay, suppose you just make the LST and NDVI for 1 year data, suppose in 2000 or 2024 25. Okay, just make the NDVI LST. So then we can easily apply the same process. So you also try, okay, this type of homework you also try to do, how to work with LST and NDVI, help of Landsat data, and further make the correlation. Okay, so now I can get the data. If you check, I can easily get the data LST and NDVI. So now this data set I want to use and make the correlation analysis. Okay, because I have the data. So now this data I want to use and make the correlation. So basically correlation is in one kind of statistical method. It used to measure the strength or direction of the linear relationship between two quantitative variables, determining how they move in relation to each other. And this correlation value, it can be positive or negative or zero. Okay, so basically strength values closer to 1 or -1 show the strong linear relationship. Okay, so while values closer to 0 indicating the weak or no relationship. Suppose I find out the 0, it means that there is no correlation between two variable. You can get a lot of idea from here. Just simply visit this, suppose correlation, simply search, then we can get. So this is the one kind of website you also visit, and then you can get the more better idea about the correlation. Okay, meaning, significant, types and degree of correlation. So what is the correlation, significance of correlation, types of correlation, positive correlation, negative correlation. This step you can easily get it from here. Okay, you can easily get all of information. This is the linear correlation. You can see this type of non-linear correlation. So you'll try to read further later. Okay, this type of correlation, then get the more better idea. Yeah. So now how I can apply the correlation with my data. So we simply make a break for 10 minutes, then we'll start again. Okay, just I make a break for 10 minutes.